Dear students, welcome to the problem solving session part 4 on Laplace transform. At first we see the basic video on Laplace transform, definition and formulas. Regarding the problem solving session, at the part 1 video we used to solve problems using linear property, and in the part 2 video we introduced first shifting theorem and how to solve problems based on first shifting theorem we saw in the part 2 video. That is, whenever the problem consists of L of e power at into f of t or L of e power minus at into f of t. And then in the part 3 video we introduced differentiation of a transform. Whenever we have a problem with t power n into f of t, how to solve these problems, we use the concept differentiation of a transform or multiplication by t power n. And in today's session we are going to introduce integration of transform. So whenever you divide f of t by t, what is the Laplace transform of f of t by t? That is what our concern today. So if L of f of t is equal to capital F of s, then L of f of t divided by t is equal to integral s to infinity Laplace of f of t into ds, or we can say this as integral s to infinity capital F of s ds, provided the integral exists. Now let us go into the problems. Before that, just recall the elementary formulas. Find the Laplace transform of sin at divided by t. So now we have t in the denominator. So we have to use the formula integration of transform. Therefore, L of sin at by t, I can write it as integral s to infinity L of sin at ds. And we know that L of sin at is going to be a by s square plus a square ds. Now we remember our formula in school days. Integral 1 by a square plus x square is equal to 1 by a tan inverse of x by a plus c. So I am rewriting this term as integral s to infinity a divided by a square plus s square ds. Here both the terms are a. Here we have x square and in our problem we have s square. Therefore I will take this a outside. Now 1 by a square plus s square integration is 1 by a tan inverse of s by a limits s to infinity. Next we have to substitute the limits. Since a is constant, I can cancel a and a. When I apply the upper limit, I'll get tan inverse of infinity. When I apply the lower limit, it is going to be the same, tan inverse of s by a. There is no change. And we know that tan 90 degree is infinity. So tan inverse of infinity is 90 degree. We have to write in terms of radian, that is pi by 2. So my answer is going to be pi by 2 minus tan inverse of s by a. And we have a result, tan inverse of x plus cot inverse of x is pi by 2. Therefore, pi by 2 minus tan inverse of s by a, I can write it as cot inverse of s by a. Hope you got the answer. Or you can stop in this step also, that is okay. Now let us solve few more problems. Find the Laplace transform of e power minus at minus e power minus bt by t. Since the denominator consists of t, we have to write the formula. By integration of transform, L of f of t by t is integral s to infinity capital F of s ds. Now integral s to infinity L of e power minus at minus e power minus bt ds. Now applying the linear property, we can find Laplace transform of each term. Integral s to infinity L of e power minus at is 1 by s plus a minus L of e power minus bt is 1 by s plus b ds. Now we know that log x differentiation is 1 by x. So 1 by x integration is log x. In general, 1 by x plus a might be any constant, x plus a or x minus a, the integration is going to be log x plus a. Therefore, integration of 1 by s plus a with respect to ds is going to be log s plus a minus log s plus b. The limits are s to infinity. And we know that log a by b is equal to log a minus log b. So we can rewrite this as log s plus a divided by s plus b, limits s to infinity. It is very important to deal with the upper limit because lower limit is yes, it will not create any change. Now to tackle the problem, I am going to take this s outside. So 1 plus a by s. Similarly in denominator, if I take s outside, 1 plus b by s, limit s to infinity. Now s's get cancelled. If you apply the upper limit, 1 by infinity is 0. So if you apply the upper limit, now a by s will become a by infinity, that is 0. So we get log numerator 1 plus 0, denominator 1 plus 0. So simply it is 1 minus lower limit will not change. It will come as it is. So I am taking this directly instead of taking this part. So the lower limit is going to be log s plus a divided by s plus b. Simplifying this, we get log 1 minus log s plus a divided by s plus b. We know that log 1 is 0. Suppose in exams, if you don't know, use your calculator, it will give you the answer directly. So it is going to be 0 minus log s plus a divided by s plus b. This is correct. Sometimes people write 1 or 2 steps extra. We know the result log a power b is b log a. So in this case we have minus. I can rewrite this as log s plus a divided by s plus b all power minus 1. So my final answer is taking reciprocal of this terms, we get log s plus b divided by s plus a. This is my final answer. Hope you understand. Next problem, find the Laplace transform of 1 minus cos a t divided by t. And very important thing, we set two sufficient conditions for existence of Laplace transform. L of cos a t by t, I cannot find Laplace transform because it violates the condition. This is an MCQ. Just remember this. Now first write the formula because we have denominator t. By integration of transform we get L of f of t by t is integral s to infinity capital F of s ds. So L of 1 minus cos a t by t, I can rewrite this as L of 1 minus cos a t ds. Now applying Laplace transform, L of 1 is 1 by s minus L of cos a t is s by s square plus a square ds. Next we have to integrate this. We know that integration of 1 by x dx is log x. So I can write this term as log s minus, see this term students, we learned in the unit 1 multiple integral. If my numerator looks like f dash of x, denominator looks like f of x, then integral f dash of x by f of x is log f of x plus c. Now just see the denominator s square plus a square. See the numerator s. Differentiation of s square plus a square is 2s. So if I multiply and divide this by 2, will be able to use the formula for integration. So this 2 will remains in the denominator. Now I will take this 2s divided by s square plus a square. So we get log s square plus a square as my answer. Limits s to infinity. Hope you understand students. Now applying limit is not advisable. Simplify the terms here. So here we have 1 by 2. Now I am multiplying and dividing by 2 in the first term so that I will take 1 by 2 in common from the denominator. Now 2 log s will be there. I said b log a is equal to log a power b. So this 2 log s can be written as log s square. So I am writing this as log s square minus log s square plus a square, limit s to infinity. Now we know the result, log a minus log b is log a by b. Therefore 1 by 2 log s square divided by s square plus a square and the limit s to infinity. So in the similar way, now we have to tackle this problem 1 by 2. Now I will take s square from the denominator. We get 1 plus a square by s square. So s square get cancelled. When you apply the upper limit, you get log 1 by 1 plus 0. When you go for the lower limit, I can retain this same because s is replaced by s. So it will give the same answer, log s square divided by s square plus a square. Now as I said, log 1 is 0. So this term gets 0. So 1 by 2 minus log s square divided by s square plus a square. Now if you bring the minus to the power, we get 1 by 2 log s square divided by s square plus a square whole power minus 1. Therefore, the final solution is 1 by 2 log s square plus a square divided by s square when you take the reciprocal. This is the final answer, students. Hope you understand. Next, if they ask a problem like this, find Laplace transform of sine square t by t. Now we have to remember the trigonometric identities. Sine square t is 1 by 2, 1 minus cos 2t. So we can write like this. So L of 1 minus cos at just now we found from the previous problem. Therefore, L of 1 minus cos 2t by t, it is going to be 1 by 2 log s square. Here a is 2, s square plus 4 by s square. But my question is 1 by 2 into L of 1 minus cos 2t by t. So if I multiply 1 by 2, my final answer is going to be 1 by 4. Hope you understand, students. Finally, we have a problem L of cos at minus cos bt by t. As usual, by integration of transform, write the formula. Now apply the formula. We get L of cos at minus cos bt. Integral s to infinity. Cos at, L of cos at is s by s square plus a square. L of cos bt is s by s square plus b square ds. Now, as I said earlier, if denominator is f of x, numerator is f dash of x dx, the answer is going to be log f of x plus c. Now in this problem, denominator is s square plus a square. Numerator should be 2s, but 2 is missing. So I am multiplying and dividing by 2. I can easily tackle the problem. So now integration of this is 1 by 2 log s square plus a square minus log s square plus b square s to infinity. Log a minus log b is going to be log a by b s square plus a square divided by s square plus b square integral s to infinity. Now, as I said earlier, if we simplify this, we get log 1 plus a square by s square. The denominator we get 1 plus b square by s square. If you take s square in common, s to infinity. Now when you apply the upper limit, it will become log 1 plus 0, 1 plus 0. So 1 by 1 is 1 minus lower limit, there is no change. S square plus a square divided by a square plus b square. We can write as it is. So log 1 is 0. Therefore my final answer is 1 by 2 minus log s square plus a square divided by s square plus b square. If you take this minus to the power, then my answer is going to be 1 by 2 log. When I take the reciprocal, we get s square plus b square divided by s square plus a square is my final answer. Hope you understand, students. So in today's session, we solved some good problems on L of f of t by t, integration of a transform or division by t.
Thanks for watching. Hope you found this video helpful. Subscribe to our channel and share it to your friends. See you in the next video. Bye bye.